going to be having a tutorial for ZeroMin how to integrate it into your run online source code if you want it. So the thing is, this ZeroMin SDK is just um exposing run online to another language called Rust, and you can pass data around them. Unlike in other SDKs or maybe APIs that you pass data through HTTP, this pass data through the binary code itself. So you can do pretty much around messing around with a lot of stuffs. This is like a demonstration of what can it do. Um, so let's do a basic one for now. So as you see here, I already created some bindings for getting file version, region.dll version, which is of course not needed. But the most important aspect here is the asynchronous function. Um, we know that async await is not existing in the older toolchains of C++. So if you're running Visual Studio 2003, 2008, of course it doesn't have await, async await functionalities on it. So this SDK is to support those on an older toolchain. However, for today's demonstration, I'll be using a newer toolchain. It's C++ 14, if I remember correctly. So Run Online is using C++ 10 or 12. I don't really remember. So yeah. So let's get started right away. Let me just explain you how the passing of data really works here. The passing of data really works here because um, I guess this is the thing. There's an STD on MSVC, right? On MSVC compilers. So they use that to translate stuffs. Now, as you can see here, we're using const char here. However, here we're using string. The main difference from this is a Rust string, which is not compatible to C++. So const char is the most compatible string for 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 C++. So it's C string. I know you know C string in Run Online. We all use C string in Run Online. So yep. So let me just explain you how this functionalities work. Right. This is the extern C. So basically, what is this? This is the one that is public to your C++ code. So this is called perform async operation, and it has a parameters or the arguments of const char, which is a string. Yeah, it's like the C string. So we have seconds, then we have a callback. Why do we need a callback? So we can call this. So this is the callback, and what output from here, as you see, this is a string, a Rust string. We will be able to get that output back into our um C++, which basically Run Online. Um, so as you can see here, we are doing an unsafe code. Here is unsafe because we convert the C char to a C string. Then it's based on a pointer, so it will try to get it from the pointer. Then it will be stored as a variable, a Rust string. Then of course after it does, once this function is done, it will be removed from the memory instantaneously. Now, we do a thread spawn because we don't want the game thread to be blocking, you know. Because if you don't use a thread spawn, the problem is the game will freeze, right? Because it's going to be on the main thread as well. So that's why we created a thread, then we move all the functions here, or I mean all the variables, all the args here, then we can create a runtime, which is the Tokyo runtime, to be able to call an async function. Since the normal STD of Rust or standard libraries of Rust doesn't have async as well. So now, as you can see here, we will wait for an output of Rust string, which is a blocking one. As you can see, this is a future one. So as you can see, future, then we can call the async. Now we can await our callback, which is the public, the callback function that is not external to C. Because yeah, you can't do that. Now we have the C string. We can get the output of our raw string into a new C string. Then if it failed to convert, it will give you a message. Um, Now we need to clone it. So basically, just copy in the memory like C++ pointers, but not really. It's hard to explain, but yeah, yeah, you'll get it once you'll be able to touch into to Rust. So it's a mute though. Now we have the results from this, the C string one that we created. Right now, once we have this C string clone, this is the result, and this is the length of the. So as you can see here in C++, it takes the bytes and the length. So this is the bits or bytes. Then from raw, it will create a C string from this pointers, and it will return. So yep, that's basically it. And for this stuff, let's talk about this in the future videos. But it's how you can actually get the data out of run online, then use it to another function, for example, an encryption, decryption, so on. So now let's actually do this async await operation. As you can see, this needs a character name, right? Now we can just compile this for a bit, make sure our FFI has a pragma once, because we need to do this in order to prevent, because we will use the libraries in like engine, run client UI, so it would be a lot of redefinitions if we don't do a pragma once. Now what we can do here now is just to directly copy this, or copy the header file directly, and this you'll have this 32-bit PC Windows MSBC. You can copy the library itself. We can go into ZeroMin, including the header file that it created. Now we can head into our source code, go into dependencies. If you have a folder like this, well, basically you can just yoink it somewhere, call it whatever. Then we'll go here in our source code. Right now, if you want to add it to a static library, so basically engine lib, engine sound lib, engine UI lib, net client lib, net server lib, or run client UI library, you just need to include it to here, additional include directories, so it can read the header file that we had for for the FFI. So as you can see here, it's already added onto mine. However, there's a different one for executables. This is where it gets tricky sometimes for some developers. Um, Now we have the additional include libraries. Of course, we need that because that's where the header file is. Um, However, if you go into linker, you need to add the library directories here, which is I already did. So you can just take a look and yoink it here. Now we have the input as well. So as we all know that the input is where we get the libraries in. So as you can see here, I've added already my ZeroMin.lib. So yeah, that's where you're going to add it. Once it's done, you'll be able to compile your your source codes. So your source code, or basically your source. Um, Take note. You need to actually have to rebuild once you change something here in the source file, because it's not directly linked into as a library in C++. You need to recompile or rebuild every time the one that has linkage to it. So for me, it's run client, so and engine lib. So every time I build for this ZeroMin, I always recompile or rebuild here. So it's just refresh the objects. Now, let's head into our example. So as you can see here, this is our callback function. So as you can see in the header file, there's no callback function. It won't be added. It won't be added. So, but however, as you can see here, we have the callback here, which is a string, raw string, and a const char. Now you're asking, why const char instead of string? Yes? Um, because what we need to pass is a const char. Yes. So for the callback function, we need to pass const char to get the C string, right? Because this string would be converted into, if you remember, it will be converted to a C string again. So it will be outputting const char and the length of it. How large is the string? So this is the response bytes, and this is how large it is. Now, let's move into this. So as you can see here, we're passing. Once we type hello Rust, it will check for a parameter. So that parameter is our seconds. If you can take a look here, this is our seconds. Okay, let me deconstruct this for you guys. Hold up. Get run data. This is where we get the run data. Get what's this? Get parameters from the command, and perform the function call. And this is just an indicator. Then of course, after that, we have our output. Now we can try it out. Yes. Now, for the use cases of this, it's a lot, trust me. So now we have this emulator up and running. Now we can just type hello Rust. Let's say 2 seconds. And now as you can see, it responded to us with "Hello, ZeroMin" from Rust. I've waited 2 seconds. What is the Rust function or the callback function from Rust that we had? So the callback function is chat name, which is a string, and the seconds for the inputs. So we're waiting. As you can see here, we're doing an await. This would be a simulation of, for example, how long your your function will take. Then it will actually wait it until the function is done. Um, and we will output a string which is called in format hello character name from Rust. I've waited x seconds, which is the parameters that we have. So we've inputted like our chat name based on our C++ code, which is from GL get client. Yes, GL game client. That's yeah. Now from that we got the name of the character since we're calling it from character data. Then it waited 2 seconds based on our input. So as you can see here, hello Rust. If we inputted like 7 seconds, now it will wait 7 seconds. And anytime now. Okay, so as you can see, hello ZeroMin from Rust. I've waited 7 seconds because it's an async function. So yeah, that's basically it. The introduction to ZeroMin. Okay, that's all. Thank you.